Hello and welcome in this fourth part of this series of webinars named Are you in the mood for better simulation educational? Today we'll see how to add a GUI, actually two, in an existing simulation configuration, for instance the one we saw last month in part 3 of this series. The agenda for this part number 4 is about adding to the models the system of interest and its environment, already bound with the simulation configuration profile, one or several GUIs in order to ease requirements validation. Later on, we will have from a practical example some snapshots and a demonstration to illustrate this simulation. Just a few words about me. I'm involved in modeling tools for several decades now, mainly focusing in embedded systems domains, avionics, transportation, automotive, and so on. My current position is independent consultant, delivering trainings and consulting for system engineering purpose, using my strong experience promoting tools such as StateMate, Rhapsody, Artisan Studio, and so on. MBSE is my core skill with a large expertise in SysML. To summarize the key messages we addressed in part 1, 2, and 3, first, simulation can help to achieve requirements validation. Then, we must isolate system model elements from other simulation and tool-related items. For instance, anything related to the environment can appear in the global representative model, but this should be clearly separated. Most diagrams can be executed, but the focus for this webinar will be on state machines for describing block behavior. We saw also how to build an environment model that will interact with our system model in order to form a global executable model, including on top of our system model the related inputs and output. We use a simulation profile for achieving this goal. Today, we will see how to add GUIs on top of such simulation configuration. Before using our mockups, we need to ensure our model from a static point of view is right. In other words, not only the syntax compliance is checked, but also the semantics of relationships of elements that are making our system model correct. We are most certainly also willing to run our system model in a closed-loop configuration by using an environment model. With Cameo, this is achieved using a configuration profile. Please refer to our previous videos describing those preliminary validation. Basically, closing the loop means we will supply to the system models input values coming from the external world, those values being requested to observe the expected behavior. This can be sensors or data coming from computers, users. Also, the outputs produced by our system model might be used for reacting to requests, for instance. This is achieved in previous steps such as interactive local simulation, as described last month with the second webinar or the third webinar, by setting values by hand in the simulation pane. But complex systems might have too many values to change. The sequence might be difficult to enter. In other words, we'd like to automate as much as possible the values setup. A similar approach will be used for testing. I mean, when applying specific test cases to our model to demonstrate requirements are fulfilled, most of the time this is useful to set the system into a specific state, in other words, put the system model in the right preconditions for executing a scenario. I've chosen to use a demonstration here instead of the screenshots I'm used to commenting now. The main reason is that mockups are animated, therefore it makes sense to see this live. Here is the project used in my book, SysML in Action with Cameo Systems Modeler, for illustrating diagrams along a generic process. As we saw in previous webinars of this series, the system is a central locking for a car, which over simplified behavior is designed using a state machine here on the left. On the right, another state machine representing the environment, in other words, the external world or dynamics context for our system. I drew several GUIs, as you will see in a minute. One to indicate to the driver or passenger expected results on the car. These are typically the outputs, here indicators and the internal light. A second GUI which aims is to simulate the ignition key buttons for locking and unlocking the car. For our system, these are the inputs. Camera Systems Modeler can use different pictures as a background, selected according to a system value, a state, and so on. This is how the graphics are animated. You can also bind buttons to events, for instance, to stimulate the model. I added to the simulation configuration those GUIs too. Animation is turned on for the two state machines. Other interesting features are available, such as execution trace, requirements verification monitoring, but we will see these in the future. Are you ready? So let's go! Now we have the model executed and our two GUIs which are executed as well. So I need to clean a little bit the screen in order to have a more convenient access to my two GUIs and watch the results. So as you can see, by default the car is unlocked until, and here this is the environment which is working there. As I explained in a previous webinar, I don't recommend to use concurrency regions for a state, except for the environment where sometimes we don't have that much choice for describing the behavior, and this is not that key. The environment is not what we want to provide requirements for. So back to our model. The goal is to use the input here, the ignition key, and to press the lock key, for instance, and see what's happening. So as you can see, both state machines are just reflecting the current state, both for the system model here and for the environment here. So, and they are of course synchronized. That means that my system model has been reaching the sealed state, while this is the same for the environment. They need to be synchronized, of course. The main difference is that for the locking state here, for instance, once I've received the lock command event, which has been generated by my button, which is hidden here, just behind the graphic representing the ignition key, then it will go to this locking state, and then we can see here that it will also execute the environment to, for instance, flash the lights on the car, or switch the light on a little later on. So now we need to check the other key scenario for this central locking ECU is to unlock the car. So let's press the unlock key here. So I can see the internal light which is coming on, and also one flash for the user to acknowledge that his command has been received and executed correctly by the system. So I can still press the lock key and see what's happening, and as you can see, the light, if it was on, the internal light is going to off, so it's the car is not lighted anymore, and there are two flashes indicating that the car has been locked. So back to locking, only one flash, and the internal line is on, and I can then press the log key again and check whatever scenarios I want to see. We could introduce some errors, or let's say some other scenario. For instance, where a door is open in the car and the system should prevent to lock the car. As a conclusion, we have seen that interactive simulation can help, meaning each time we have modeled a state machine on activity, we can validate them by running simulation. But of course, when we have a complete model, it's more difficult to use it in an iterative way, as this is painful to initialize all inputs, change values, trigger events from the external world. In other words, that means we need to close the loop to bring our system model next to an environment model, where inputs will be connected to outputs and vice versa. So back to our large Boolean value, this will be managed by our environment model, which will be in charge of mimicking the external world. Adding mockups to such simulation is an efficient way for running scenarios to validate our system model. Next month, we'll see how to check that our system model does satisfy our requirements. Here, I mean textual requirements. Cameo Systems Model has a very nice feature allowing to dynamically validate requirements while executing the model. So, thank you for attending. Stay tuned for the webinar number 5 next month about adding checking models compliancy with our requirements. You can still reach me through my email or find more detail in my book, which is available now. Goodbye.